Mystery failure near Mars. NASA declares MAVEN probe unrecoverable after mysterious failure near Mars amid interstellar object tracking. NASA has officially confirmed that its Mars orbiting spacecraft MAVEN has been declared unrecoverable after suddenly going offline following an unexplained malfunction while operating near the red planet. Now it's time to break down every angle of this story on our AI podcast.
Imagine you're tracking a multi-million-dollar piece of technology, like an absolute masterpiece of engineering.
Right.
And it has been flawlessly orbiting another planet for a decade. It's doing exactly what it was built to do, sending back these streams of invaluable data every single day.
Yeah, totally reliable.
Exactly. And then, without any warning, it just starts spinning completely out of control. The telemetry goes erratic, the signal drops, and the entire spacecraft just goes pitch black.
It goes from being this triumph of human achievement to, well, basically a silent, tumbling piece of metal in the void. And it happens in a matter of hours.
It's wild to think about.
It is. I mean, we tend to view space exploration as this highly sanitized, meticulously controlled endeavor, right? But moments like this, they kind of script that illusion away. They show how fragile our foothold out there really is.
Yeah, it really does. And that sudden catastrophic failure is exactly what we're unpacking in today's deep dive.
And a fascinating one.
It really is. So we are looking at this stack of incredibly interesting notes, mission logs, and excerpts from a source called the MAVEN Anomaly: Silent Signals and Interstellar Mysteries.
Lots of great details in there.
Oh, for sure. And our mission today is to figure out the sudden, entirely unexplained death of NASA's MAVEN probe. We really need to separate the concrete, verifiable facts of what happened to the spacecraft from, well, the absolute storm of scientific and internet controversies out there.
Right, especially regarding the interstellar object it was tracking right before it died.
Yes, exactly. And finally, we'll look at the massive gap this leaves in our ongoing exploration of Mars.
The intersection of established orbital mechanics and the complete unknown is what makes this specific anomaly so compelling to look at.
Oh, I totally agree.
You have this highly reliable spacecraft, a sudden catastrophic hardware failure, and a highly unusual celestial visitor. And they're all converging in the same narrow window of time.
Yeah, the timing is just nuts. And I kind of want to set the scene for December 6th, because the timeline of how this unfolded is honestly pretty eerie.
It really is.
So MA goes offline. And the closest thing I can compare it to, for anyone listening, is like being on a road trip and driving into a long mountain tunnel.
Well, that's a good way to put it.
Right. Like, the radio is going to cut out. You fully expect your GPS to drop momentarily while you pass under the solid rock, and you just wait for it to pick back up on the other side.
And in space, that kind of blackout happens all the time.
Exactly. The probe passes behind Mars, the signal drops, but this time, well, the car just never came out the other side of the tunnel.
Right, because orbital mechanics literally dictate those exact blackout periods. As the probe passes behind the planet, the solid mass of Mars physically blocks the radio waves.
So Earth just has to sit there and wait.
Yeah, Mission Control fully expects that silence. But when that expected silence stretches from minutes into hours and the telemetry fails to lock back on,
that's when the panic sets in.
Exactly. The reality of the situation sets in. You are dealing with a dead asset.
Wow. And to really understand why this particular loss is so devastating to the infrastructure we've built around Mars, we have to look at what MAVEN was actually built to do.
Because it wasn't just doing one thing.
Right. It had been orbiting since 2014. And from looking at the sources, it seems like it wasn't just, a lightweight camera taking pretty pictures of craters. It was a heavy-duty relay station.
Yeah, MAVEN, which stands for Mars Atmosphere and Volatile Evolution, had a dual mandate.
Okay.
So scientifically, it was there to study the upper atmosphere. But operationally, it acted as a vital communications relay between Earth and the rovers actually driving around on the Martian surface.
Like a giant space Wi-Fi router.
Pretty much.
Yeah.
Because Earth and Mars are constantly moving in their orbits, right? So direct line-of-sight communication with a tiny antenna on a rover just isn't always possible, let alone efficient.
Well, that makes sense.
Yeah, so orbiters like MAVEN catch the data packets from the ground and use their massive high-gain antennas to beam that data across millions of miles of deep space back to Earth.
So it's basically a crucial piece of interplanetary infrastructure.
Exactly.
And then on December 6th, it goes into the tunnel and just fails to emerge. But the data NASA did manage to recover before the blackout showed the probe behaving abnormally, right?
Yes. It showed it entering an uncontrolled spin, draining its batteries and failing to transmit usable data.
Okay, so I'm trying to picture this death spin. If a spacecraft is just floating in a frictionless vacuum, why does spinning kill the battery?
It's a great question.
Because it reminds me of my phone dying in minutes when I'm in an area with terrible Wi-Fi. But I don't know if the physics of power drain are, like, the same out in space.
Well, the physics actually share remarkably similar underlying logic, but with a fatal mechanical twist.
Okay, how so?
So your phone is burning battery power by constantly energizing its internal antenna, right? It's desperately searching for a tower. MAVEN is burning battery by firing its internal reaction wheels. See, spacecraft don't just sit perfectly still. They use heavy internal spinning tops called reaction wheels to maintain their orientation.
Oh, like gyroscopes.
Exactly. If the spacecraft gets bumped or needs to turn, it changes the spin of those internal wheels, using gyroscopic inertia to point itself.
So if the spacecraft starts tumbling, those internal wheels try to fight it.
Right, they go into absolute overdrive. The onboard computers realize the main communications antenna is no longer pointing at Earth.
Uh-oh.
And worse, the solar panels are no longer pointing at the sun. The system panics. It spins those reaction wheels faster and faster to try and arrest the tumble.
Oh, wow.
And eventually, the wheels hit their absolute physical speed limit, a state called saturation. They literally can't spin any faster.
So what happens then?
At that point, the entire spacecraft bus begins to physically tumble.
And once it's tumbling, it can't catch the sun anymore. So the charger is essentially unplugged.
Exactly. It is expending maximum energy trying to stabilize while taking in zero solar energy.
That's a bad combination.
It gets worse. Space is a thermal nightmare. A spacecraft relies on pointing specific sides toward the sun for warmth and other sides toward deep space to radiate heat.
Oh, I didn't even think about the temperature.
Yeah, in an uncontrolled tumble, that thermal management completely fails. The battery isn't just draining, it is plunging into a deep freeze.
Man.
Once the core voltage drops below a certain threshold in those temperatures, the hardware just freezes solid. The communication systems are entirely crippled.
So you're left with a multi-million-dollar piece of hardware just frozen and spinning in the dark.
Unrecoverable.
If that was the end of the story, it would just be a devastating day for aerospace engineering. But the context of this failure is why we're really talking about it today.
Right, the timing.
Because MAVEN didn't just die randomly on a quiet Tuesday. The start of this catastrophic hardware failure happened immediately following a very specific, highly unusual observation.
Yes, it was tracking an object known as 3I Atlas.
Right. So what exactly is 3I Atlas?
Well, 3I Atlas is a fast-moving interstellar object passing through our solar system.
Okay.
The mainstream classification designates it as an Oort cloud ejecta, basically an interstellar comet-like body, and MAVEN was uniquely positioned to observe it during its Mars flyby.
Now, the sources mentioned MAVEN was about 18 million miles away from 3I Atlas during this observation.
That's correct.
I mean, to a layperson, 18 million miles sounds impossibly far to get a good look at anything, let alone take a meaningful picture that could be considered a primary scientific observation.
It does sound incredibly far.
How does a probe actually gather data from that kind of distance?
Well, it doesn't rely on optical photography in the way a consumer camera does. AIDEN is equipped with an imaging ultraviolet spectrograph.
Okay, so it's not just snapping a photo.
Right. Instead of just taking a picture of the rock itself, it looks at the light from distant stars as that light passes through the cloud of gas and dust coma surrounding the comet.
Oh, interesting.
Yeah. Different chemical elements absorb specific wavelengths of ultraviolet light. By looking at the gaps in the light spectrum, essentially reading it like a chemical barcode.
Chemical barcode.
Yeah, MAVEN can determine the exact composition of the gas boiling off the object from tens of millions of miles away.
Okay, so it takes this spectroscopic reading of 3I Atlas, and then shortly after, the reaction wheels saturate, the spin happens, the batteries freeze, and the comms are crippled.
That is the timeline, yes.
But NASA's official stance is that the exact cause of the anomaly remains unknown. They state investigations are ongoing, but they officially maintain there is no physical evidence linking the mechanical failure directly to 3I Atlas.
Right, and that represents the rigorous standard scientific position. Correlation does not equal causation.
Sure, yeah.
Just because event B followed event A does not mean A caused B. Proving causality, especially from millions of miles away on an unrecoverable spacecraft, requires concrete data.
I mean, that makes sense.
To bridge an 18 million mile gap with a physical cause, like an electromagnetic pulse, a targeted kinetic impact, or a gravitational anomaly, well, that requires mechanisms that standard physics cannot currently account for in a simple comet flyby.
Right.
And NASA has absolutely no telemetry suggesting any of those forces hit the probe.
Okay, I hear that, and I respect the rigorous demand for evidence. But the pattern recognition part of the human brain makes it incredibly difficult to accept that timeline as pure coincidence.
It's definitely a hard pill to swallow.
Right. Like, if I am in the woods taking a picture of something highly unusual and my camera suddenly violently explodes in my hands, I am absolutely going to assume the two things are connected.
Sure.
Regardless of whether I can prove the mechanical failure of the lithium-ion battery inside it, you know.
Skepticism of the coincidence is entirely warranted.
Okay.
In fact, it is driving the intense debate in the astrophysics community right now.
I bet.
The timing is objectively extraordinary. But as analysts, we have to separate the suspicion of the timing from the reality of the data. We have to ask what, physically, could have caused the perturbation that sent those reaction wheels into overdrive.
And that tension between the incredibly suspicious timing and the lack of a known physical mechanism, it really brings us straight into the scientific controversy surrounding the object itself.
Yes, it does.
Because brilliant minds are fiercely debating the true nature of 3I Atlas. I mean, the mainstream consensus is that this is just a natural interstellar wanderer, an icy space rock. What is the counter perspective here?
Well, researchers like Harvard astrophysicist Avi Loeb are stepping in and pointing to specific anomalies in the data AVN gathered.
Okay. And to be clear to everyone listening, we aren't taking sides here. We're just looking at the source material and impartially reporting what these different experts are saying.
Exactly. Our job is just to lay out the arguments.
Right. So what is Loeb pointing out?
Loeb and his colleagues are focusing intensely on that spectroscopic data we talked about earlier. The key detail highlighted in the sources is the detection of unexpected methane emissions outgassing from 3I peoples.
Okay, so methane. Why does methane matter so much in the vacuum of space? I know on Earth we associate it with natural gas or, like, agriculture, but what makes it a trigger word for astrophysicists looking at a comet?
It's because methane is highly unstable when exposed to stellar radiation.
Really?
Yeah. High-energy ultraviolet photons from the sun basically smash into methane molecules and shatter their chemical bonds. They break them down into carbon and hydrogen very quickly.
Oh, I see.
Because of this photodissociation, if a spectrograph detects an intact methane signature in space, it means that methane was produced or released very recently.
Oh, wow. Finding is like finding a warm cup of coffee in an otherwise abandoned room. Like something had to have made it recently.
Precisely. Now, methane can absolutely be produced by abiotic, entirely non-biological geological processes.
Like what?
Subsurface water interacting with certain types of rock, for instance. But on Earth, it is overwhelmingly a byproduct of biological life.
Okay.
Finding unexpected, actively venting methane on a fast-moving object from outside our solar system forces a critical question. Is this just a rare geological oddity, or could it be a biosignature?
Which is a massive question.
It is. And this specific anomaly leads Loeb to discuss theories involving panspermia.
Panspermia. So if I'm trying to visualize panspermia based on the sources, is it essentially treating these comets like a cosmic dandelion?
That's a great analogy.
Like where the rock and ice act as the fluff, carrying biological seeds or complex organic precursors across the galaxy, just hoping to take root wherever they crash into a habitable environment.
The cosmic dandelion analogy captures the underlying mechanism of the hypothesis beautifully. Panspermia suggests that the building blocks of life are distributed throughout the universe by meteoroids, asteroids, and comets. Loeb is arguing that a fast-moving interstellar object, actively venting a potential biosignature like methane, should not be reflexively dismissed as a standard comet.
So he's basically saying the anomaly in the data warrants treating the object as something far more significant than just, Oort cloud ejecta.
Exactly. He argues that the mainstream consensus requires extraordinary evidence to claim anything other than a natural comet, which is fair.
Sure.
But he pushes the boundaries by asking if our standard conservative models are sufficient to explain the unique data points we do actually have.
It's a really compelling debate.
It is. And science advances through this exact kind of friction. The value here isn't in prematurely declaring 3I Atlas an alien seed ship or confirming it as a boring ball of ice.
Right. The
real value is in recognizing that multiple rigorous perspectives are actively debating its nature based on the final data MAVEN sent back. Both perspectives are crucial for pushing the science forward.
Yeah, that makes a lot of sense. It's a massive debate, but we shouldn't let the mystery of the suspect overshadow the legacy of the victim here.
Absolutely not.
3I Atlas is gone. It's moving out of our system, but the encounter marked the definitive end of MAVEN. 10 years of orbital science, just gone on December 6th.
It's a huge loss.
But looking at the mission reports, NASA division leaders emphasize that despite the sudden death, the mission was a fundamental success. Like, it literally changed our understanding of Martian atmospheric evolution.
It really did. It finally proved how the atmosphere disappeared.
Yeah. Prior to MAVEN, we had theories, right? But we lacked the longitudinal data.
Exactly. We know Mars used to be a much wetter world with a thick atmosphere capable of supporting liquid water on its surface.
Right.
Over a decade, MAVEN provided the definitive mechanical proof of how the solar wind stripped that world bare.
And I really want to understand the mechanics of that stripping process, because the solar wind isn't actually wind, right? It's not like a breeze blowing the air away.
No, not at all.
So how does a planet physically lose its atmosphere to space?
Well, Earth has a molten active core that generates a massive global magnetic field, right? That magnetosphere acts as a shield, deflecting the solar wind, which is actually a continuous violent stream of charged plasma ejected from the sun.
Wow.
Mars, being smaller, cooled down billions of years ago. Its internal dynamo stopped, and its global magnetic shield just vanished.
So the shield drops and the planet is exposed.
Completely exposed. Without the magnetic field, that high-energy solar plasma crashes directly into the Martian upper atmosphere.
That sounds intense.
It is. The radiation ionizes the gas molecules, giving them an electrical charge, and then the magnetic force of the passing solar wind physically grabs those ions and accelerates them out into deep space.
Oh, wow.
MAVEN observed this process happening in real time. It showed that this sandblasting effect accelerates dramatically during intense solar storms.
So it provided the precise physical mechanism for how a potentially habitable world transitions into a frozen desert.
Yes, exactly.
That is incredible. And the sources are clear that the terabytes of data MAVEN secured over a decade will fuel Mars research for years. So the science isn't dead.
Not at all.
But operationally, going back to the idea of MAVEN as interplanetary infrastructure, there is a very practical fallout here.
There is.
Does the sudden death of this probe mean we essentially just lost a massive portion of our bandwidth for the rovers currently on the surface?
Yes, it creates an immediate and severe operational bottleneck. The Mars telecommunications network is a delicate web.
I can imagine.
We do have other orbiters acting as relays, so the rovers are not entirely cut off. But losing MAVEN removes a massive point of redundancy.
This slows everything down.
Significantly. It means the scheduling windows for surface rovers to transmit their high-resolution images and complex drilling data back to Earth just became significantly more constrained. The surface teams now have to do the exact same amount of science with a fraction of the data uplink capacity.
Man, it really brings the reality of space exploration down to Earth. We are so used to seeing the pristine, 3D renders of planetary orbits, and we forget that this is a highly volatile frontier.
It's incredibly hostile out there.
We've tracked a massive journey today. We started with a decade-long, highly successful mission that unlocked the deep mechanical secrets of how an entire planet lost its atmosphere to the solar wind.
Yeah.
And then we hit this sudden, jarring halt. A mysterious, unrecoverable spin triggered, or at least occurring exactly during the flyby of an interstellar object actively venting methane, an event that has completely fractured the scientific community.
It serves as a profound reminder of the stakes involved. You're dealing with tens of millions of miles of distance, the unforgiving thermodynamics of a vacuum, unpredictable mechanical failures.
And the constant potential of encountering the deepest mysteries of the universe, all simultaneously.
Exactly. It requires immense humility to operate in that environment.
It is the great unknown, and it rarely gives up its secrets easily. And, I want to leave you with a lingering question to ponder long after we wrap up this deep dive.
It's a good one to think about.
Think about that timeline one more time. MAVEN's ultraviolet spectrograph captured its final readings of 3I Atlas from 18 million miles away, right before the reaction wheel saturated. Right before it entered that tunnel on December 6th and the thermal systems failed.
The very last moments.
What might be hidden in that very last packet of data transmitted before MAVEN went into its death spin? Could the true nature of 3I Atlas and the physical cause of MAVEN's sudden demise be locked together in those final silent frames?
It leaves you wondering.
It really does. We're still waiting for the car to come out of the tunnel.
Okay, one question for you. What could realistically cause a long operating Mars orbiter like MAVEN to suddenly lose stability, spin uncontrollably, and go permanently offline right after observing an interstellar object passing near Mars. Don't forget to comment it. Thanks.